In this video, I am going to go through how to calculate standard deviation and z-scores by hand. This is the simple data set we will be working with for this example. After reading that doctors and researchers estimate that people fart between 10 to 20 times per day, my brother Jimmy decided to keep a record of the number of times he farted per day for a week. This data set does not include nocturnal emissions. Now that we have our data set, let's look at our formula. This is the formula to calculate standard deviation. To calculate the standard deviation of our data set, we are going to break this formula into multiple steps. The first thing we have to do is determine how each individual score deviates from the mean. This is part of the numerator of our standard deviation formula, the sum of all x minus the mean. However, since we haven't calculated the mean yet, we will need to take a step back and calculate that before we can go any further. To calculate the mean, we need to add up the total number of farts Jimmy counted for the week, or the sum of all x. To do that, we add 15 plus 12 plus 25 plus 16 plus 14 plus 15 plus 13. When we add those numbers together, we get our sum of all x values, 110, which means Jimmy farted 110 times that week. To get to the mean, we divided the total number of farts by the number of days, which is 7. 110 divided by 7 equals 15.714285, and so on. The American Psychological Association requires us to go out 2 decimal places. In this case, we will round to 15.71. With this part now complete, we can now start calculating our deviation scores. To calculate how each individual score deviates from the mean, we will subtract the mean, which is 15.71, from the number of farts for each day. For example, on Monday, we will subtract 15.71 from 15. The deviation score for Monday is negative 0.71. We will go through and do the same thing for each additional day of the week. This is a visual representation of how each of the scores deviate around the mean of 15.71. The black line going across the screen is the mean. Scores above the black line are scores that are higher than the mean, or in this case, days where Jimmy farted more than 15.71 times. Scores below the black line are scores that are lower than the mean, or days that Jimmy farted less than 15.71 times. Looking at this graph, you can see that Wednesday deviates the most from the mean. It seems like chilly day in the cafeteria affected Jimmy's output of farts for the day. Thursday is the only other day that is above the mean. The rest of the week's scores are all below the mean. Our next step is to square each of the deviation scores. But before we do that, let's talk about why we square the deviation scores. We have to square the deviation scores because when we add up all the deviation scores, they sum to 0. We have to square the scores to get rid of the negative signs and get the sum of total deviations from the mean. Now we can square the deviation scores. When we square the deviation score for Thursday, for example, we get 0.08. When we square the deviation score for Wednesday, we get 86.30. Our next step is to calculate the sum of squared errors. The sum of squared errors is the total of the squared differences between each observation and its group's mean. In our example, it would be the total of the squared deviation scores between how many times Jimmy farted on each day of the week and the average number of times he farted for the entire week. To calculate the sum of squared errors, we simply add together all the squared deviation scores that we just calculated in the previous step. Looking back at our formula for standard deviation that I introduced at the beginning of this video, the sum of squared errors is the numerator of that formula. The sum of squared errors is the total of all the squared deviation scores added together. We are going to take all of our deviation scores, 0.5, 13.76, 86.30, 0.08, 2.92, 0.50, and 7.34 and add them all together. When we add all of those squared deviation scores together, we get the sum of squared errors, which is 111.4. The formula to calculate the variance is simply the sum of squared errors over the sample size minus 1. To calculate this, we just need to plug in the information. We just calculated our sum of squared errors, so we can plug in 111.4 in the numerator. In the denominator, we will plug in our sample size. In this data set, our sample size is the number of days Jimmy kept track of how many times he farted. Since he kept track for an entire week, we have a sample size of 7. After we subtract 1 from our sample size of 7, we will end up with a denominator of 6. Thus, our variance is 111.4 divided by 6, which equals 18.57. Going back to our original formula for standard deviation, we can see that we have already used all the parts of the equation except for the square root sign. Another way of writing the standard deviation formula is the standard deviation equals the square root of the variance. Since we already have the variance, we can simply take the square root to calculate our standard deviation. The square root of 18.57 is 4.31. Now that we have calculated the standard deviation of our data set, I would like to know what the probability of Jimmy having less than 25 farts a day is. To do this, we will need to calculate the z-score for that day. To calculate the z-score for Wednesday, we need to plug the numbers into the z-score formula. The z-score formula is x minus the mean all over the standard deviation. X stands for the individual score, or in this case, the number of farts Jimmy had on Wednesday. When we plug that information in, we get a numerator with a score of 25 minus our mean of 15.71, which equals 9.29. Our standard deviation of 4.31 is in our denominator. 9.29 divided by 4.31 equals 2.16. Thus, our z-score for Wednesday is 2.16. Is the z-score of 2.16 considered an extreme score? As a general rule, z-scores above or below 1.96 are considered extreme. Since 2.16 is above 1.96, Jimmy's number of farts on Wednesday would be considered an extreme score. It would also be known as an outlier. To get back to our original question, what is the probability of Jimmy having less than 25 farts a day? We will need to look at our unit normal table and find 2.16, the z-score we just calculated. Then we will need to decide if we need to look at the probability value in the body or in the tail of the distribution. Because we want to know the probability of scores lower than 2.16, that is the largest part of the distribution. The large part of the distribution means we need to look at the body. When we look at the probability value that is in the body, we will see that the probability is 0.9846. So what does this all mean? It means that Jimmy had a 98% chance of farting less than 25 times in a day. The alternative is that there was a 2% chance of Jimmy farting more than 25 times in a day. As it turns out, Chili Day Wednesday resulted in a significantly higher number of farts compared to the rest of that week. If Jimmy continues to indulge in Chili Day Wednesday, he should probably plan on avoiding people entirely and potentially sleeping on the couch so he doesn't disturb his partner.